type of things, right? Any one of you, do you know what is the function of this? Yes.
I'm not sure, sir, but I heard that it suppresses the high frequency something noise or something like this. I'm not sure.
Yeah, you're up to some point. Yeah,
Electronics frequency.
it's something like this electromagnetic wave. Okay, it will bar the. It's something like it's called a Ferranti or something. Okay, so this will mainly block the radio frequency and electromagnetic wave. Okay, means like entering to the systems. So this, when you plug in the AC supply, okay, this will have, there will be a electromagnetic wave, okay, or a radio frequency wave. So this will block this. So please try to find out on detail. Okay, there are, if you just search on the net, okay, you'll find on detail. Okay, what is the function of this? Because we never think about all these type of things. Okay, but these things are quite. It will not be there in any of the syllabus or anywhere. Okay, but people, we try to overlook all these type of things, but it has a function actually. I was just yesterday. I was just going through the Facebook again. In a Facebook, there they have written on detail. Okay, and sometimes we never like try to find out all this type of things. Okay, but it's quite important. Sometimes we have to know the what is the function of different things which is present on the in a day-to-day life. Okay, I think let's start with our last unit. Okay, our last unit is AC to AC converter or AC regulators. Okay, in this AC to AC converter, okay, we have three sub unit. Okay, that is AC voltage controller, AC regulators. Okay, voltage controller, that is controlling the voltage. Okay, either off on controls. So when you see the controller, okay, converter, AC to AC converter. Okay, actually we're thinking of converting a fixed AC to a variable AC. Okay, you're just converting this, means like one form to another. So even the regulator, okay, means when you talk about the regulator regulating the voltage, output voltage, okay, even if we talk about this, means regulators are like, it can be a manual operators. Okay, the automatic voltage regulators are there, uninterrupted power supplies are there. These are the regulators actually. Even the switch mode power supplies. I know you must be thinking that what is the function of SMP, switch mode power supply. Okay, if you just open and see your, if you have a desktop, okay, you will see that there is a SMP, switch mode power supply. Okay, in a CPU, before when the power is just blocking, it goes through the SMP, switch mode power supply. So, and the third one is a cycloconverter. Okay, in cycloconverter, we are converting from one form to another form. Okay, and these forms are now in this. Okay, we are not talking about the controlling the voltage. Okay, but we can convert, means like frequency can be from one frequency level to another frequency level. So if its supply frequency is 50 hertz, and if your device is working on the 110 hertz or 150 or 200 hertz, okay, now this cycloconverter will help to like convert. It's a converter, means like from one frequency level to another frequency level. And in this case, okay, we can have a single phase cycloconverter, three phase, or a thyristor control reactor, TCR, TCS, okay, the thyristor control reactor, or thyristor switch capacitors. Okay, these are some of the things, okay, we have to go through in this last unit. So power electronic is basically all these converters only. If you see from first unit is only the power semiconductor device. Okay, after that all these are converting from one form to another form. So power electronic devices will is helping to convert from one form to another form. Even in the last unit, that is the AC to AC converter. Okay, this we use the thyristor, or we call as or ACR. Okay, so in this also we are just trying to control the output. If the input is fixed, and we can control the output. Output can be based on the need, based on our desire. So what should be the output? Means what voltage level is required for our particular device. So that is quite important to know, that voltage devices, or what are the different names, like the different gadgets or different equipments requires a different voltage level. Okay. Now, if this is a definition, okay, is a thyristor power converter which convert fixed AC to a variable AC without changing the frequency. So in regulator, what it basically does is that it converts is a thyristor power converter, means where the thyristors can be used. So it's a switch only. Okay, if we talk about the thyristor, as I have been telling you, that is a thyristor we are using as a switch. So we have to control, we have to know that how many times it is on, how many times it is off. So based on this, we have to know the duty cycle of that T on divided by the total time period, okay, and how many times it has been on and how many times it has been off. So switch on and off. So we are not in this, in AC regulator, okay, we are not talking about the changing the frequency, okay, we are just controlling the amplitude only. If you see in a small signal analysis also, analysis can be either we have to either we have to do something with the amplitude or with the frequency. So in this case, we are in AC regulator, we are not talking about anything about the frequency. Frequency is 1 by T. Okay, TF is equals to 1 by total time period. So in AC regulator, we are not touching anything, we are not doing anything with the frequency, okay, but with the total time period, but we are controlling the controlling the amplitude. So that controlling can be a phase control. Okay, if you try to see, okay, the phase control can be possible if you just draw a sine wave input, sine wave. Okay, the how long the phase, the positive half cycle should be on and how long it should be off. So it depends on the person, okay, or the requirement on the output. Okay, we can switch on for how long we can switch on that in a phase control, how long, if we just draw a sine wave, okay, that portion phase, the controlling of the phase can be possible. So or we can do have a switch on and off control. On and off control means how many times the switch is on and off. So based on this, we can have output control on the amplitude of the voltage. So it's also known as a voltage controller, or AC voltage controller. So it has a different name, okay, AC regulator, okay, or automatic voltage controller. So we are, means that how the voltage is regulated at the output. So other one is a psychoconverter, which I have told you that input power at one frequency level, at the output power at a different frequency levels. We can convert the input power at one frequency to the output power at a different frequency with one stage conversion. So stage conversion means that it does not have a multiple stage. Okay, so it can be converted from one frequency level to another frequency level. Of one means that input power of one frequency, and if you require a different frequency level, especially some devices require a higher, can be it can work only on the higher frequency level. But if we try to stay, our supply frequency is just 50 hertz, okay, and it depends on the different countries. Like in European, some of the European countries, they have a 60 hertz, 110 volts. So it depends on the location, especially in Southeast Asian country. We talk our supply frequency is just 50 hertz. Maybe some devices might work at 60 hertz, or maybe might work at 100 mega, means 100 hertz. Okay, depends on the type of equipment we are using. So for that we require a cycle converter. So we need to know exactly at what frequency level are we converting at the one stage conversions. This can be conversion can be possible at a multiple stage. If you could remember that in an amplifier, okay, in public PA systems, okay, the amplifier used are not a single amplifier, it can be a multi-stage amplifier. So the gain of the first amplifier is given to a second stage. So in this case, there's nothing like a multiple stage in cycle converter. It has to be converted into one stage conversion immediately at one stage, one level. So this is a block diagram of a AC regulator. If you see here, the input AC input voltage and variable AC output voltage, or means there your output voltage is variable. So you require a variable supply. Maybe some devices that might require a multiple different type of voltage level for a different component. For that purpose, we require such type of device, such type of regulator which can regulate that maybe your input might be fixed, okay, and output can be a variable is AC supply. So can you just give me an example, okay, that why do you use this AC regulator?
Sir, is it like this auto transformer, sir? Because auto transformer is also fixed to variable, no, sir?
Exactly, means of course in this case, okay, we are talking in transformer. What we are using we are using a transformer. Okay, it serves a purpose. Okay, but similar to that of a transformer. Okay, transformer also we are talking about multi tap transformer, right? Uh, or we can have a different level. Basically, main function of a transformer is either to step off or step down, right? So whether the voltage can be step up or step down. In this case, okay, we cannot step off the voltage.
No, sir. I mean this one, auto transformer, sir. In auto transformer, we can control, no, sir.
Yeah, we
We
can control the voltage.
yes,
It serves the same
right.
function actually. But auto transformers are it is if you talk okay, the auto transformers are it can be used for higher voltage level or it means like we cannot have a in case of a auto transformer okay, we cannot have a control over the frequency, right? So
Yes,
it serves a similar purpose. Okay, the output can be a variable. In auto transformer, output can we can change the output voltage, right? But there are some means like restriction on in case of a auto transformer means like we cannot change the frequency level. Or in case of a cycle converter, or if you talk about the regulator, means like a regulator, okay, the frequency can be converted. So, but we can have a multiple output voltage in case of a regulator. And even in auto transformer, we can have a different voltage level, right? So it serves a similar purpose, but this can be a compact. If you talked about the regulator, okay, regulator can be a compact thing, means like it can be a regulator can be a more reliable than reliable and compact. Okay, that in terms of a size, also in terms of reliability, also. Because we are talking about here in regulator, in AC regulator, we are talking about thyristor. We are using a power electronics devices, but you know that what is auto transformer, right? So it is a transformer. So we it also serves as output voltage can be a variable output voltage. So it is almost means like there are certain similarities between these two things, but it's not exactly same. If it is exactly same, what's the use of having a regulator actually? But it has a specific like we can have a specific output if that component requires just 12 volt and you can design a circuit in such a way that if that circuit requires 12.1 volt we can design a such type of circuit. Even in auto transformer also we can regulate a voltage in certain level, means we can have our output voltage. Okay, so do you have anything to can you give me the example of this regulator, AC regulator? Where do you use this AC regulator? Means application. Where do you use this AC regulator?
in stabilizer it used.
In even in television or refrigerator. Okay, what do you use actually?
First we use this stabilizer, no, sir.
Stabilizing voltage means we are controlling the voltage, right? Output voltage. So that is controlling the output voltage. If the voltage goes to a certain means like a level, okay, we are controlling the output voltage. Okay, so it is voltage stabilizing a voltage. There is automatic voltage stabilizers are there. We are controlling the output voltage. Means that there are certain that means like it is exact not exactly means regulate. It's the regulating actually. Means it's regulating the output voltage. Input might be fluctuating, okay, but we need to have a fixed output, means that it can operate at a certain level, so that the device does not get spoiled. These are some of the applications like lighting, illuminations control in AC power circuits. The illumination controls means like in case of if you want to control the illumination level at the means like AC power circuit, okay, then this are some of the application where the AC regulators are used. Induction heating key. So this is the application of AC regulator is in case of induction. You must be having induction cooker at home. So where induction heating elements are there. So it is used in the induction heating, industrial heating, and domestic heating purpose. So if you have a heater in some of the heating systems, okay, they use this AC regulators. So transformer type changings. So that on load transformer type changes, they use this regulator. Speed control of induction motors. So speed control can be possible with the help of the AC regulator, AC magnet control. So all these there are so many applications where we use a regulator, AC voltage regulator. Auto transformers, transformer with taps and magnetic amplifiers. So these are the in auto transformers also we can use, or AC regulators can be used. So the main purpose of we can use regulators. Actually, what we are trying to control the output voltage. Input is a fixed, so if you require a different type of multiple output, then we can use the AC regulators. One of the example of the AC regulator is the auto transformers. Means like auto transformers are, what is the function? The input is a fixed, so you can have a variable output. So with the taps and the magnetic amplifier were used in above applications, so we can use a magnetic amplifier. So thyristors and triacs AC regulators are used. So why thyristors and triacs are used in AC regulators? Because it has higher efficiency, compact in size, flexibility in control. Even if you see, okay, the regulator, fan regulator, okay, triac and diac is used. Now, if you see in olden days, they use rheostat as a rheostat control of speed of the fan, or resistor is used to control. But it is not compact. If you see nowadays, you just have a small size of a switch. So it is efficient also. You can have a step regulation also. You can have as a dimmer circuit, means like you can control based on if there is no steps control also. So there is smooth control can also be possible. So that's why it's a higher efficiency, compact in size, flexible in control. So it can be a smooth control can be possible, or it's also suitable for the closed loop control because of the low control power and fast response. Response time is quite fast. So, but what are the disadvantages of this controller? Is presence of harmonics. This is one of the most drawbacks. Okay, the disadvantage of all this type means like presence of harmonics. So how do we remove harmonics, or how do we overcome this harmonic? We have also seen in case of inverters, okay, there are different pulse width modulation. PWM is used. In some cases, the filters are used. So to remove these higher order frequencies this is one of the disadvantages of these controllers. Is because we are dealing with the AC, right? So, and the load voltage, particularly at a lower output voltage, so there will be a harmonics presence on this. So there are two types of thyristors control used in practice to control AC power flow. They are, as I've told you, the on and off control. So controlling can be possible with the on and off. So because the switching speed has to be kept in your mind. So how fast the switches work actually means that it's just a switch. Okay, we are talking about the on and off. Means how fast it can connect the load with the source. So connection time. Use switch means like as a switch to it is thyristors are used as switch. So how fast it can connect the load source to the load, and for the few cycles of the input AC supply, and then disconnect. So for the few cycles it will connect to the source, and for the few cycles it will disconnect to the source. So it's a switch. Okay, we try to we can control the output by connecting the load to the source, for the few cycles and disconnecting the load to the source for the few cycles. So it's a switching, how fast with the switches work actually, how fast the thyristor works. So thyristor does act as high speed contactor. So it's what the function is, contactor or a high speed AC switch. So it's a thyristor, it works as a contactor. So other one is a phase control. So in phase control, the thyristors are used as a switch. So even in the phase control or on-off control, okay, in phase control, what it's done is that to connect the load circuit to the input AC supply for a part of every input cycle. So for the part of the input cycle, okay, it is connected to the source, is connected to the load, and other part is disconnected. It's like it's chopped. It's like same like a chopping. Okay, that certain portion of the input cycle is connected to the source, is connected to the load, and certain part is disconnected to the load. Means part of the input cycles. It means the AC supply voltage is stopped. It means like it is stopped. So how long means it's not the same like what is the duration of the switch on and off period. So how long the input cycle is on. So thyristor switch is turned on for the part of the every half cycle. So it is part of the half cycle is turned on, and that input supply voltage appears, it will appears to the load, and the remaining part is turned off and disconnected the AC supply from the load. So it means that in phase control, what we're trying to do is that the input cycles, certain portion of the input cycle is switched on and certain portion of the input cycle is turned off. So the trigger delay angle. So now the delay angle or the firing angle, okay, comes into picture. So trigger delay angle or firing angle is defined as the phase angle. So value is like omega t. So thyristor turns on and the load current begins to flow. So what is the triggering? At what point are we going to trigger this? So based on this, the output voltage will also depend on this. So thyristor AC voltage controllers uses a AC line commutation. So in this, they uses a line commutation or AC phase commutation, because when you talked about these thyristors, okay, we have to keep in our mind that how are we going to do the commutations are possible. So in this case, thyristor AC voltage controller, the commutation is one of the most important. How are you going to switch off this thyristors? So they use the line commutations or AC phase commutation technique in this. So thyristors in an AC voltage controllers are line commutated or phase commutated. So means like it's a line commutated or it's sometimes also known as a phase commutated, because in this case the input supply is AC. So input AC voltage reverses and become negative during the negative half. So you know that it means the AC voltage will be negative during the negative half cycles. The current go through the conducting thyristor decreases and it will fall back to zero. It means like it becomes negative during the negative half cycles. So it naturally is turned off. So during the negative half cycles, it will naturally turn off, and when the device current fall below means that it falls to zero. So phase control thyristor, which are relatively inexpensive. So this is quite cheap. If you try to compare this, becomes it's quite cheap, inexpensive. It's like converter gate thyristors which are slower than fast switching inverter grids. So thyristors are normally used in this case. So it becomes quite cheap also. So relatively inexpensive. So these are the two different types of thyristor controls. Means on off controls to control the AC power flow. So on and off control. Other one is a phase control. So if the applications up to 400 hertz, okay, the triacs are available to meet the voltage and current rating. So if it is that up to 400 hertz, the triacs are used in this case. Most commonly, okay, triacs are up to 400 hertz. Okay, the triacs are available in the market. So because of this line commutation, the natural commutation, there is no need of extra commutating circuit. Because of these conditions, okay, there is no need of extra. If you have to have a commutation circuit, okay, extra commutation circuit, then naturally the cost inbuilt will be higher. So because of this advantage of AC line commutations, okay, it does not require extra commutation circuits are not required. It means that the cost required means like becomes cheaper. So the circuits for the AC voltage controllers are very simple in this one. Due to the nature of the output waveform analysis and derivation of expression for performance parameter are not simple. So if you try to see, okay, if you try to analyze this output waveform, analyze derivations, all this, okay, because our loads are not purely resistive load. We have to analyze anything, okay, with the RL load, because in reality, okay, the loads are never purely resistive load. Loads can be a RL load. So we have to do the analysis. It's not as simple as we try to analyze with the R load. So especially for the phase control AC voltage controller with RL load, okay. But most practical loads are RL loads, so you have to consider the RL load only in case of well analysis and designing of AC voltage controller. So if you are trying to design a regulator, AC voltage regulator, okay, then we have to consider RL load, not R load only. Of course, the analysis is much more easier, but practically will not have a pure resistive load. If you try to add L, okay, then the analysis become a little bit complicated. So these are some of the type of AC voltage controllers. There are two types based on the type of input AC supply applied in the circuit. So this is a single phase AC controller, that's 230 volt at 50 Hz. That it can be further classified as a unidirectional or a half wave AC controller, or bidirectional or full wave AC controller. So it can be a three-phase AC controllers, okay, unidirectional, same as that of single phase. It can be a bidirectional with same as that of three-phase. I think I'll just take half an hour, and okay, I think we have enough time. I think we can finish our syllabus. Like we are just in the last unit, okay. So do you have anything to say? Yes. Let me take the attendance. Who is absent today? I think there are only 25. I think 20. How many of you are there?
24, no, sir. Including sir, 25.
Yeah, 24. 24. There are, I think, 4. Yeah, I think all of you are there. 22, 3, 4 of are repeaters and re-repeaters, right? 1, 2, 3, 3, I think. So do you require, means, do you want, if suppose if the college reopens, okay, do you need to like brush up some of the topics, or means do you need to like do the means like face-to-face teaching in some of the topic? Which one do you prefer to have? Suppose if the college reopens and if we have some time for the revision, which topic do you prefer? Means you want a revision on like a face-to-face teaching.
If we can this summarize in all this
All the
unit, no,
units,
sir.
right? And even what I feel is that some of the we could not do much problems like okay numerical part, okay. So even what I feel is that we can do the summary of almost all the unit, okay. And if suppose if you are asked to come back to the college, okay, we can even do some of the problems in all, means like few problems on all the units, right? Or you don't want to do the problems, numerical
Sir,
problems?
we have to solve numerical, no, sir.
I think we need to solve some of the numerical problems because it's quite difficult to do the numerical problems online, right? So at least if we get 1 to 2 weeks, okay, we can solve few problems, few numerical problems from each of this unit, and we'll try to. And the practicals, we have not done anything on the practicals. Okay, so you have to do the practicals. I think there are around 11 practicals are there. For practicals, you can even do 2-3 practicals in a day. I think you have already started with the practical, right? You have already done, I think, BI characteristic and tag and
Yes.
drag. Have you done this too? Did you do BI characteristic of SCR?
Yes, sir.
Then second
Yes,
one,
sir.
characteristic of drag and drag.
This
No,
one
Bhaviman,
not done. This one not done, sir.
only first practical is done, right?
Yes, sir.
But we never know what will be the decisions of the decision of the government. Okay,
But there will be many practical, no, sir, for us. Estimation practical also there. C++ also we will have practical.
C++ practical online, Mabia.
Lalu pha hebe venigi chia do ansum chi do, sir.
online ni mabe sir. Assignment di
Online
dash jeans practical gi.
sir.
Power electronics ki mo machine practical, then C++ 3, then other
Only 3, sir.
only 3, right? So in power electronics, okay, if you really do in one practical period, suppose if you're given a two periods, okay, you can even complete 2-3 practicals in one period. Because BI characteristic you have already done, okay. The characteristic of tag and DAG, if one group does, if you divide into 2-3 groups, okay, it means in a practical time. I feel that you can do even 2-3 practicals in one go, I think. Because these are quite simple, okay. Characteristic of DAG and TRAG is similar to that of ACR, right? So input output characteristic of FET and MOSFET. What I feel is that you might have already done the FET and MOSFET even in a small signal analysis, right? In analog electronics. Did you do MOSFET characteristics? Anna, baby, I don't know whether you have done it or not. MOSFET, the FET effect transistor, this is the. I don't know whether you have done it, but it's quite easy. Okay, just input output characteristics. Study of different triggering circuit of ACS, different type of triggering circuits are there. It's quite. Then half-wave rectifier. It's quite simple. This half-wave rectifier is you have done in the analog electronics, but in this case you have to use the STR. In case of analog electronics, okay, you have done with the diode, I think. So you have to use the SCR. So construct a single phase control bridge rectifier. This is similar to your output characteristic. You will get similar to that of in analog electronics. In full wave control center tape rectifier, step off, and observe the step up and step down. I think this is a chopper. Step down, construct a step down and step up choppers. Then characteristic of inverters. Then how to control the speed of the fan using AC regulators. How do we control this using AC regulator? So these are practicals are quite simple in power electronics. So you will not take much time. So how is the data consumption? By now you might have means how much means at once. What means like what package do you choose? Means which package, like 699 or 11? What is the data consumption? Guarantee Lami, suppose if you recharge for 199, okay, guarantee days left.
199 gi nam sa milame sir. You recharge for 1299 sir.
That would be any Zoom demo. I think most of you have registered on this. Free 60% free data do me the 7012 the day. Zoom can be accessed to that data also. Recharge vacancies. And
No,
do me
sir.
60% means 60% data so Jindibat Yanigi, it's low. Telecom data still. If you recharge additional 60% jump to do, but you can access from 7 to 12 only. And if Zoom, I think Zoom is possible. Zoom is included on this. Zoom's, YouTube's, and some static that educational websites are possible, I think. But now, okay, I think most of the syllabus are completed. I think there are not much classes this year. I'm saying, actually, maybe only around 30 to 40 minutes. Faculty might take that much to go. So I think I'll stop here. Okay, just I think you finish your data. So we'll continue in next class. I think it's on Friday. But I don't know. I have a duty. Okay, Friday. I don't know. Let me check. Okay, I'll inform the CR. Okay, whether I can take your class on Friday or not, because I have a patrolling duty on Friday. But I'll inform the CR. Okay, regarding this. Okay, till then. So take care of yourself. Good.
Thank you, sir.
Thank you, sir.